your attention? So, how many of you guys were able to make knots?
Yeah.
Okay, everybody was okay? It took you an hour. There's one in every crowd that they have to learn how to make knots. Okay. So, what we are going to do is, well, we're going. Okay, is everybody ready?
Yes.
Okay.
So, are we going to need our tax for this?
Yeah, because you're going to need to make another one. I'll give you one in a second. Oh, come on, you didn't lose your tax, did you?
Well, one fell when I was talking in the hallway too. They don't say it very well.
Okay, well, I know, I told you, make sure that you do it on, you had an extra piece of cardboard at home, or, on your notebook or something, and, that you can do that, okay? So, anybody know what shape we're talking about?
An ellipse.
Okay, we're talking about an ellipse. Okay, and so we're going to come up with a definition, and you're going to be writing. I'm going to give you notes on definitions, but what happened? She stepped on it, jumped up and down on it. Okay.
I'm pretty sure it's stabbing the foot.
All right, so let's talk about our definition of a circle. And we know that a definition of a circle is going to be the set of all points, right? A circus is going to be the set of all points, a given distance being my radius, from a given point. Okay, so let's talk about what we're going to have for a definition for an ellipse. Okay, now it's going to be the set of all points, okay, isn't it? And everybody has a slightly different looking one, but it's going to be the set of, oops, I just lost my, my points, my tax won't stay in. Okay, it's the set of all points, but is it a given distance? You need to think about what that given distance is. Because as opposed to a circle where my given distance is always the same, look at what happens in an ellipse. And what is controlling the size of my ellipse?
The string.
This string.
The taut.
Okay, the tautness of the string. But I want you to look at what happens to this string. If I could measure this distance, and then I measured this distance, isn't that the length of my string? And doesn't that length change? Like now when I have my point here, is this length longer than it was when it was here?
Yep.
Okay. Is the distance from here to here different than from here to here? Isn't that a different length? Okay, I thought you were not agreeing with me. Okay, but what is true throughout?
The entire length of the string stays
The entire length of my string stays the same. Okay, that's not changing. So part of my definition is going to be the sum of the distance from these two fixed points, okay? And the two fixed points are constant. So I'm going to give you a definition to write, and let's see if we agree with that. You might want this on a separate piece of paper.
Oh, put it in my book.
Put it in your book, and eventually what we're going to do is, there are lots of different labels that go on the ellipse, and I'm going to ask you, we're going to label your ellipse, and that's why I gave you glue sticks. You're going to be gluing them into your book with all the labels. Okay? So here is our definition. I'm going to turn the light off. The definition of an ellipse. it's the set of all points P in a plane. Okay, so we're talking about in a plane, a coordinate plane, where the sum of the distance from P to two fixed points is constant. Okay, so those 2 points didn't change, and that strength didn't change. Total length didn't change. I don't know if I have one that's working. Here, let me try this. Okay, so a definition of an ellipse is the set of all points P in a plane, where the sum of the distance from P to two fixed points is constant, and each of the fixed points is a foci. And if you want, next to that, you can make a little sketch of what that means. Just do a little sketch and draw your string. Okay, so the distance here, and I can just say A and B, these are going to be, that's what's controlling my ellipse.
Wait, does that say each of the fixed points?
Where the sum of the distance from P to two fixed points
After that,
is constant. Each of the fixed points is called a focus. Okay, so and this is a vocab word. We're going to write these vocab words on your thing. Okay?
What does it say after that?
And the plural is foci. So focus, those of you who take Latin, you have a singular focus, and the plural is foci. Right?
Yeah.
We talk about the radius, and we talk about the plural of radius is radii. Okay, it's the, get the word, how you change the endings for conjugate. It's the conjugation of the verb. Okay, so let's look at your paper now. Okay, hold on a second. And I'm taking out my dots, my thumbtacks, and what are these fixed points? The foci. And I'm going to label them as such.
what if ours are really bad?
You're drawing,
Yeah.
then you might want to do another one. Okay? So you should have a foci.
Is to make the strokes.
Okay, so you might want to do a sketch right now, because I'm moving along. I'm not going to give you time to make another one right now.
Yeah, I'll just draw.
Okay? So you have a foci. Everybody who has your sketch? What we need to do, we're going to take our paper, and they should be somewhat symmetrical. Would you agree that an ellipse is symmetrical? And let's fold it, and those of you who took geometry, you've done some constructions with patty paper, you know I'm going to do tip to tip and crease. Eli, I'm doing tip to tip, and I'm folding my ellipse this way. And how many points of symmetry does this have? Can I fold it over horizontally? Okay, so I know that there has 2 points of symmetry here. And I'm going to crease it again. And when I do this, I should have some lines that are hard to see, but I'm going to draw those in. Okay? So can everybody see that I have drawn in, oops, I have mine upside down. Okay. Okay, a geometry student, what do I call a line?
Diameter.
Well, it is, but it has a beginning and an end. So do I have a line,
Segment.
or a
Segment.
segment? So I have a line segment, okay? I have two line segments here, and I'm going to make sure that you can see my line segment. And what do you think this point is right here?
The center.
Center, okay, so let's label that the center. And technically, is the center the midpoint of the line segments?
Yes.
Okay, so I know that I have the midpoint. Okay, I have two vocab words here, and I have a major and a minor arc, not arc, a major and a minor axis. Which one do you suppose is your major axis, and which one would you say is the minor?
Horizontal's meat.
Why do you think that the horizontal is major?
Bigger.
It's bigger, exactly. Something is major, those of you who are baseball fans, isn't there a difference between a major league and a minor league?
Yeah.
Yeah, okay. So major, minor. So we're going to say that the major league, okay, the 2 points on the ellipse at the end of these segments, the ones that are further away are the major axes. And the ones that are actually closer are the minor. Axis. All right, so we have a major and a minor axis. Oh, okay. I have another word for you. These endpoints, what do we call endpoints commonly on triangles?
I thought those were the focuses.
Vertex?
Vertex, good. Good job, Zach. So this major axis and this endpoint, the endpoint are vertices. Okay, so I have a vertex and the vertex here. There's one here and one here. So the endpoints, I'm just going to make that plural. Endpoints are vertices. Okay, and we have our foci over here. Our foci were the fixed points. Okay, so
Why don't we ever use the ellipses in real life?
well, that's a good question. We will do some word problems, and you'll see the application. One of them would be on scientists who are looking at orbits. Our orbits are not circular, but they happen to be elliptical. The Earth travels around the sun in an ellipse. There are architects build buildings that have elliptical shapes, and actually we'll read about a famous, one of the properties of an ellipse. Okay.
So the major axes and the endpoints are the same thing?
Well, no, the major axis describes the one that the vertices are further away from the center. Okay, the vertices are just these points, but the major and the minor describes how far it is from the center.